So this is the cleaned weld area in the inside of the hub. So you can see the crack, depending on the light, it goes from here all the way to here. Now I want to clean this off really well because cracks can be very small and you don't want to weld up and then miss a spot over here, and then it's just going to continue. So this area has been abraded off with a stainless steel wire wheel. Very important here, never ever ever use steel, carbon steel brushes or wheels on aluminum because you'll embed rust particles into the surface and you're going to have big problems. So this is stainless steel. It was cleaned with acetone first, abraded away, then cleaned repeatedly until this comes off clean. This could take a while, but you got to keep wiping it down and wiping it down with acetone until you no longer get any black or gray material coming off the surface. Some of that's going to be dirt, some of it's iron oxide. Now if you look at, aluminum oxide. So if you look at this carefully, there's a shiny area here, there's a duller frosty kind of area around it, and then you have the anodizing over here. This dull area is aluminum oxide, okay? So that is the self-protective layer that aluminum forms on the surface. Aluminum oxide is a refractory material, which means it does not like to melt. It's high temperature. Another common example of aluminum oxide that you probably have in your house is the abrasive material on a nail file. You know, like one of those paper nail files, the sandpaper, or even ordinary sandpaper is aluminum oxide. So this material that is on the surface of aluminum is exactly the same as this material that's on sandpaper, okay? Aluminum oxide sandpaper. It's very, very abrasive. It doesn't like to melt, and you must remove it before welding on aluminum. You have to. There's no way around that, okay? It penetrates, generally it's like maybe 10,000ths of an inch thick, and aluminum is self-protective. So if you clean this off and then say leave it over the week and come back on Monday, you have to re-clean this again. That is formed through the interaction of aluminum and oxygen in the air, okay? So it's self-protective. That's why aluminum is used in marine applications and why it doesn't rust or corrode, because it's self-protective. Stainless steel does the same thing. You also need to remove that layer from the stainless. In the case of stainless steel, the oxide layer reforms in about 20 minutes. So you go to lunch, you gotta come back, you gotta clean it off again. So once you start, you gotta go. So this is on the inside over here. So looking at the alloy that these are made out of, I wanted to see, you know, what is this thing? So what I can see on the surface, I see machining marks over here. So what I know is probably a cast rim that was then subsequently machined to size. So the information of how a particular thing was made gives you some information of how it's going to weld, okay? Forged materials, forged metals, or press, like say a cold rolled material which has been pressed together, are going to weld differently from a casting, in which the structure is rather loose and it doesn't, you know, it's like welding a sponge, and you'll see when you do it yourselves. Also could have lots of trapped gases as well, which can cause issues. So in welding this, what I'm going to do next is I'm going to take a carbide, I'm going to groove out the weld on this side, okay? Actually, most likely I'll weld the other side first. What I'll do is I'm going to groove that first, okay? Get rid of the damaged material in here, give myself a place to put a weld. I'll probably drill 2 small holes at either end of the crack. Maybe it's not necessary, but it'll prevent propagation of the crack, okay, from going any further if it starts to crack while I'm welding it, because I don't know what this is. I looked up what alloys are used, and I really didn't find any concrete information on what kind of alloy it is. So I'm going to take all my precautions here of worst case scenario of what might happen, okay? And sometimes that's what you gotta do, because if you don't know what this is. So I'll drill 2 small holes to prevent the crack from propagating any further. I'll probably preheat this area a little bit as well. Sometimes preheating is good. It warms up the aluminum. It's not cold today, but it warms the aluminum, and sometimes any kind of oil or other debris will migrate to the surface and come out, and then you can wipe it away. So sometimes that helps, especially if it's an oily, like engine part. You can repeatedly heat it and cook all the oil and grease out of the surface. It can help a lot. So that's going to be the next procedure here.